Welcome back on the stage of GPI Paris Summit 2021. Of course, you're still with us here live and streaming from everywhere in the world or in person here with us at Institut de France. As you all know, COP26 has entered its second week and it's 1 minute to midnight on Doomsday Clock. While all types of Earth observation are concerned by the impact and possible contribution of artificial intelligence, we'll focus for the next 90 minutes on problematizing and illustrating more specifically the relationship between AI-powered Earth observation and climate change. To do so, I'm going to be joined in a second by 4 amazing guests on this very stage. And here they are with me here in Paris, Emmanuel Bacri, the co-founder and president of the Scientific Advisory Board of NAME-R. You'll definitely dive into it in a few seconds. And with us online, Begum Demir, you're the professor in the Faculty of Electrical Engineering and Computer Science in Berlin. Abhilasha Pawar, they're the founder and of Blue Sky Analytics and management team member of A Climate Trace. And the co-moderator of this segment, Pierre-Philippe Mathieu, the president of the Phi Lab Explore Office, European Space Agency. Thank you so much for being here, either here with us in person or remotely. Let's introduce the panel, maybe first with you, Pierre-Philippe, if you may. Why is AI becoming an essential tool when it comes to Earth observation?
Okay, so good morning, everybody. Can I just check you can hear me?
We definitely can.
Yeah, I can hear you.
Good. So if we can put the video in the background, that would help. So first of all, apologies I couldn't be with you. I'm really delighted to be invited to this session. Space is really offering a new perspective on our planet. So you have satellites going around the planet and monitoring on a routine basis, and they provide data on what's happening for our climate, ocean, atmosphere, etc. You can see here a few data sets. So they measure a variety of variables that helps to understand our climate, how the ocean and atmosphere interact to shape, if you want, all the interaction in the Earth system. And we get big data. We get of the order of petabyte. And by the way, this data is open and free, so you can go online and download it. And we need new technology like AI to make sense of this. They are like different bricks, different pieces of a puzzle, as you can see here. And we need to put them together, make a synthesis, and enable prediction. So the properties of AI, the scalability, the fact that it's a new paradigm, learning from the data, help to make sense of this, help to understand all these patterns between these different variables. So for example, you have El Nino, which is a huge oscillation in the Pacific. Thanks to this data set, you can understand the impact of El Nino on vegetation, on the carbon emission, etc. So we are looking for AI talent to implement their techniques to extract the real information that decision maker needs out of these data sets and also create business with it. So Marjorie was mentioning that there is the COP ongoing. Most of the data that provide evidence on climate change come also from this global perspective from space. They help understand our impact on this planet, and they are really important to have a consistent monitoring around the globe. So techniques such as AI help scientists to understand where we are heading with the Earth system and our climate. Thank you.
Yes, I get that. To put it in a nutshell, Pierre-Philippe, if you may, we can say that solution-powered, AI solution-powered, when it comes to fight climate change, can definitely be profitable and sustainable at the very same time. Now we'll dive into some more presentation because, of course, you've been working on various different issues when it comes to Earth observation and AI. Well, it's a simple rule, actually, for every one of our guests. Everyone has 5 minutes to express her or herself. This is definitely my role here to be a timekeeper, so I'm doing it as much as I can. Maybe start with you first, Begum. Begum, you're definitely going to dive on the issues surrounding the processing of Earth observation data.
Okay. Hi, everybody. I'm not hearing you well, but I think it is my turn now.
But we can hear you perfectly, so that's
no, I'm
all
not
it counts.
hearing you. Yeah. Okay. So I will be shortly introducing our research fields. So I am the head of the remote sensing image analysis team at the Faculty of Computer Science of TU Berlin. And I'm also leading recently a new team on big data analytics for Earth observation at the Berlin Institute for the Foundations of Learning and Data. So in our teams, we aim to develop methods for processing and analysis of large-scale Earth observation data acquired by airborne and satellite-borne systems. And to address these challenging problems in this field, our research activities lie at the intersection of remote sensing, big data management, and machine learning. And we are aware that to deliver the maximum value for Earth observation, it is necessary to develop infrastructures, methods, tools, benchmark datasets for the analysis of large-scale Earth observation data. And almost 2 years ago, we developed Big EarthNet, that is a benchmark archive containing Sentinel-2 multispectral and Sentinel-1 synthetic aperture radar data to drive research and innovation on machine learning for Earth observation. We believe that it opens promising directions to advance studies for the analysis of Earth observation data in different Earth observation applications. Okay, at the center of our research, we are interested in developing accurate and scalable techniques for satellite image understanding, search and retrieval from massive archives, and we are particularly interested in Copernicus archives. And the methods that we develop, they provide foundations for knowledge discovery systems that index and query the content of large-scale data. And recently, we are investigating how we can deploy our tools in these platforms. And this will allow us to test and validate our machine learning models in operational scenarios. So by this way, we will achieve a semantic-based image search and retrieval for the Earth observation data archives. Of course, we are interested in architectures and algorithms for scalable processing and integration of big heterogeneous Earth observation data for different remote sensing problems. And we recently envisioned Agora.io, that is an Earth observation ecosystem infrastructure for sharing, finding, and running datasets, algorithms, and other tools. Actually, so in short, Agora.io, it's a collaborative platform for AI, for Earth observation applications that aims to handle all the assets in terms of data, algorithms, compute resources. Yeah, so this is at the moment at the vision phase, but we would like to make it running soon. So before ending, I would like to just emphasize two different topics in the direction of AI for Earth observation that we are currently investigating. One of them is on continual learning. So as you may know, when a machine learning model is trained with the available training samples, it may be fixed, and which is the regular way for Earth observation applications. However, the repeat pulse nature of satellite orbits with high speed, like high temporal resolution, together with new satellite missions, results in rapid growth of data archives. and continuously learning from a stream of recently acquired Earth observation data is very important. This requires updating the model parameters over time as new training samples become available, but existing systems directly retrain the full machine learning model with the previous and new training data. This is not practical for large-scale Earth observation applications. So to address this problem, we are recently working on continual learning and the related tools, which will aim to continuously learn from the new acquisitions. So we think that this is a very important research direction. And then I would like to also very shortly emphasize the importance of integration of Earth observation data with georeference socioeconomic data. Actually, this has been recognized as highly valuable, particularly for studies on public health and human settlement observation. We believe that such integration can increase the privacy and data protection concerns, which current Earth observation systems are not yet fully equipped to protect. So that's why we believe that to protect privacy while conducting scientific research to improve Earth observation using large Earth observation and socioeconomic data sets is very important nowadays. And we have recently started the work in that direction. And we are addressing these problems at the moment by developing federated learning-based methods and approaches and related tools.
Thank you very much, Begum.
Okay.
And we'll definitely dive into the massive amount of data you have to curate out there in a few seconds. But let me turn to the men around the stage here with me. Emmanuel, of course. You, of course, have a great experience with the Health Data Hub, and you've just been, co-founding Name R. I bet you have a lot of experience with a different, like use case when it comes to data and Earth observation itself. The mic's open.
It's open. Okay, great. So let me talk about Neymar. So Neymar is a deep tech startup that is listed on the Euronext growth market since last June, that gathers more than 50 employees. So our main mission is to create, transform, enhance data of territories, buildings, and environment in order to meet the challenges, the main challenges of ecological and energy transition. The Neymar takes its name from a vision that aims at describing the whole physical world through data. So that's Name Reality, Name R. So it's been now 5 years, almost 5 years, that we are collecting a huge amount of non-personal data from a huge amount of sources. And these data are of very, very various types. So it's, of course, structured data like cadastral data, social data, energy-related data, climate data, but also, of course, unstructured data like Earth observation data, like aerial and satellite images. Now, the idea is to take all these data and extract all the information that is contained in this data and gather them and make a huge join using geolocalization information at various levels. So geolocalization at a territory level, geolocalization at a city level, at a street level, at a parcel level, and down to the building level, using postal address that is able to specifically point to any building or any parcel. This huge join is extremely technical step because we are dealing with very, very various heterogeneous data and very heterogeneous ways of geolocalizing the data. When we get that, of course, we don't have complete data. I mean, we have to use machine learning and AI again to fill up the holes in order to cover, as of today, the whole France territory and very soon other countries. At the end of this very long data pipeline, we are delivering for each building in France, each parcel, each postal address, more than 300 attributes. So the roof geometry, the roof material, what objects are on the roof, the number of floors, the living surface, the construction date, the heat type, the energy performance diagnostic, whether there is a swimming pool or not, and many, many more. Okay? In the data set of Namer, we have more than 6 billion values of such values, and each of these value is delivered with a confidence indicator, a confidence index that keeps, of course, improving every day, because every day we have access to more data that are used by our algorithms, and every day we improve our algorithms. Now, all these data are useful for energy transition, ecological transition. Our customers use them either to enrich their own data, making a join at any other level, postal address or territory or whatever, or they can be used for prospecting purposes, or to monitor a portfolio of clients or whatever. So we can, or they can, with the help of Namer data, answer to very various questions. Let me name a few of them. I wrote them down, like which of my buildings should be prioritized for thermal insulation? How many very poorly insulated buildings are there in my municipality, and where are they? Give me let's say, the addresses corresponding to the best top 1,000 buildings in France that have the highest solar energy potential. Okay, so we can answer all these questions using our data. Of course, as you can imagine, a lot of these attributes are built using state-of-the-art machine learning and deep learning algorithms, but we are also building our own. We have proprietary deep learning algorithms that are able to deal with very heterogeneous data. So they are taking as input aerial satellite images, 3D LiDAR images, stereo vision, and also geometrical data like cadastral data, but also regular structured data like energy data or whatever. Okay, and so this is a very, very complex task, and we still work on it, of course. We have overcome a lot of challenges already, thanks also to a lot of partnerships that we already have, but we keep building partnerships. We're very open with private companies, with public institutions, academics, with a lot of various expertise going from climate change, energy transition, aerial images, but NLP, deep learning, computer vision, and all that. Of course, we are left with a lot of challenges that we have to face, and I guess we will be talking about some of them in the discussion.
Oh, absolutely. You're reading my mind. Abhilasha, I want to address you a question because, yes, climate change can be monitored. Of course, speaking of experience, you have a tremendous record there at Blue Sky Analytics and Climate Trace. So, how to monitor climate change?
Have totally highlighted lights and more sensors. I always like to give the analogy of telecommunication. Back in the days, Europe and the US used to have telephones and telephone lines, and then the rest of the world just moved to mobile phones and 4G and 5G monitoring. In the past, we have used a lot of sensors, but in future, we can jump in with satellite and the combination of sensors to give the resolutions, both temporal and spatial, using AI, machine learning, cloud computing, and one of the best innovations in Sky is APIs. So in our company, and we're just a 3-year-old company with like 20 people, all under the age of 30, so we're very young and small team, but we're analyzing about 40 terabytes of data points, let's say air quality, from 250 data points to 3.3 million data points for India.
Thank you very much. I think we just have probably one bad experience with your bandwidth and network. Probably the producing team here will be in touch with you just to make sure that the sound and image is perfect for the next question. Let me throw actually the next question back to Pierre-Philippe. Again, I mean, at ESA, you have a lot of course, experience on Earth observation. So how AI is actually transforming the way Earth observation is handled by space agencies?
Okay, so what we do at ESA is to create mission, launch mission, operate mission, and then collect the data. And we do this with a system also called Copernicus, which does this routine monitoring of the environment and give the data to the citizen of the world to create knowledge and service. So this data is big, it comes from different sensors, it has different sampling, different error bars. So it's a huge problem of putting all this together, of making a kind of microscope or macroscope on the planet using all these different sensors. And that's where AI is really good at. It has this scalability, this ability to learn from the data all the time. So it's a paradigm, if you want, a paradigm shift, whereby the algorithm is created by the AI itself by learning on the data. So it's perfect for big data issues. So you can understand that it transforms totally the way we do things. In fact, it's reinventing the whole value chain of Earth observation, whereby you spend a lot of efforts now in the data preparation, so augmentation of the data annotation, quality control. Then you put your software. Most of them are open and free, and they come from other communities, so we need to adapt them to our problems. Then you train, and then you can do the inference either on the Earth or on the satellite. We will discuss this later. So in a nutshell, a startup that is doing, starting today with space data would be very different from a startup that started 10 years ago, because it would create a new value chain, new way of computing, and in fact, a new generation of services. So this is why it's a very exciting time for us to be here, because space is not about space, it's about the data we generate from space. And we need to connect with the AI community to make the most of this data.
Absolutely. Thank you so much, Pierre-Philippe, for that. And of course, this curation of data also opens wider possibilities and opportunities for other nations when it comes to space and the new space market and area. Let's dive into another part of our discussion, if you may. And of course, if you do have a question or reaction to one of our speakers, you know what to do. Just, post your question on the platform, or if you're here with us, raise your hand. In like 30 minutes from now, we'll definitely open the Q&A session with our guests. First, Begum, I promised I'll be back with you and dive into this amount and a massive amount actually of data you have to curate here, because the collection of sufficient number of reliable training samples is, of course, time consuming. We have to say it at some point, complex, but also quite costly in operational scenarios. So do you have a solution to make it easier?
Yes, thank you. I am happy that I can also hear you now. So,
wow, that's improvement.
Yeah. So actually, of course, we are aware of the fact that to train accurately machine learning models, we need large-scale annotated data sets. And the performance of the models depend on the reliability of such data sets. And this is very time demanding and costly for Earth observation applications. So if you are dealing with large-scale applications, it's much more critical. And to address this problem, we are making use of available thematic products. So they can be also called as digital maps. They can be available at global scale, continental scale, national scale, regional scale, and so on. For example, for Europe, we have Corinne Lancover map, actually provided by the European Environmental Agency. It provides different levels of land use Lancover labels. And we use this data set to create our Big EarthNet benchmark data set. So, of course, I mean, land use, land cover classes that are related to physical phenomena, characterized by specific properties like spatial variability of classes, non-stationary spectral signatures, and so on. And they are very difficult to be modeled without reliable labeled data. This is, we agree on this. But these thematic products, although they can provide us labels on land use, land cover, they can also carry noisy data. So some labels can be noisy, like wrongly annotated or missing, and so on. So to address this problem, we also work on designing label noise robust models. So thematic products are, the use of thematic products is the right way, but then the machine learning models should be also designed to handle possible noise in the labels that can be existing.
Thank you so much for making our lives way easier when it comes to curating those super crucial data. Actually, Pierre-Mathieu, I'd like to dive with you into the question of technology transfer, because of course, again, as an international space agency, and working closely with startups, as you mentioned a few minutes ago, there's definitely a question about how to facilitate this transfer and technology transfer. Do you think also in a way that we should probably create an international agency or another regulatory body to better help when it comes to facilitating these transfers?
Okay, that's quite an open question. I'm not sure about that. This is more a political question. What is important is to put some oil on this technology transfer, because here we have the kind of perfect couple. We have AI and we have Earth observation, and the meeting of the two creates really new opportunities. This meeting is happening, but it can be accelerated. And we are working on it with partners, the European Commission, the whole ecosystem, in order to provide the tools, the data, but what we call AI-ready data set, which is the data formatted such that the AI community can really have a go at it and use the algorithm, and also presenting the people with problems so that this data can help them. So in that context, if you want, what is really important here is that AI is just a tool, okay, in the toolbox, but a very powerful one. What we need to do is to bring together the different actors, the people who can provide solutions, the people who have big problems which are at the scale of the planet, such as climate change, global change, you name it, put them together, shake it, and then the technology will be transferred, because people will work on something which has a big purpose, can create knowledge, and can also create a return for business.
Thank you very much. So if I follow you closely, there is no planet B, but there is no AIB either. We definitely have to work closer on those technology transfer to make it happen. And speaking of AI as a powerful tool, again, to emphasize the way we can curate and we can better highlight Earth observation, let me turn the question to Emmanuel here. Do you think, Emmanuel, that AI will be able to find new insights in data and also generate new products and services?
Well, it's already done. Let me just talk about a few use cases that we're operating already. So I already told you about this solar potential energy. So basically working with satellite images, 3D LiDAR, cadastral information, and some climate information too, we're able to really detect the roofs. Each segment of the roof, we are able to detect whether there are objects on the roof or not. We are able to compute the slope, the orientation of the roof, so we can really compute the potential, the solar irradiation of the roof, so the potential energy. And we can also, of course, know whether there are trees around the house or the building. So is it going to be hard to put the solar panels? We can know if in the street there are other possibilities also to put solar panels so that you can reduce the cost and so on. So we do all that at a very micro level, and this is very new, and this is really possible because we have this information of the satellite images or Earth observation images. Another use case, we just started a partnership with CNES, with Dawex, Airbus, Dassault, and Thales in order to detect urban heat island. Now, we don't detect them at a macro level. This was done for a long time already. We detect them building by building. So we know exactly what are the buildings inside this island. So we can, ultimately, we will be able to say on which building we will have to act in order to make this heat island less hot. So where to put the parks, where to maybe paint the buildings in white, and there are many, many ways of doing so. The third use case I have to mention, so this time it's not related to NAME-R, it's the thing you were mentioning at the beginning. I have another job. I'm the Chief Scientific Officer of the National Platform for Health Data, which is called the Health Data Hub. And of course, there are huge applications using Earth observation on health and environment. And actually, we're in discussion with ESA currently in order to try to build a partnership on that. But it's clear that we have to, again, perform some join with Earth observation data and individual health data in order to make some research and find some new results on health and environment.
Looking forward to hearing more in depth about this new partnership with the Health Data Hub and ESA when it comes to mix and matching health data and Earth observation. And you definitely mentioned, Emmanuel, and we also mentioned it at the very beginning of this session, the crucial and obvious fact that Earth observation and AR are indeed helping the fight against climate change. Abhilasha, let me give it a try again with you, if you may. Can you actually dive into the solution, into the crucial impact you've been experiencing throughout your work here?
So first of all, apologies. I'm dialing in from Glasgow, and everybody in the world has come in here. So the internet and all the infrastructure services are facing a brunt, which kind of gives an example of what happened with climate change. We will have a huge decline in just available natural resources that we have, and everybody across the world will have to greatly optimize how we use our natural resources. And that is where blue sky or the role of AI and satellites come in. I'll give some very strong use cases. For instance, we've seen high cases California, Amazon, Siberia, Italy in the last year, which have so much implication. House pricing, danger to our infrastructure, to our critical electric assets, to our infrastructure lines. And this is where we really need to both get information in advance on how or how the infrastructure we are building or investing in could endanger forests. Are we putting in a huge electric line in very close to a forest? And as we get into 2024, 2025, and temperatures really rise up, the two might really be in a conflict. So these are some of the things that we need to start thinking about, and that is where the role of data really plays in. I will give a second huge example on extreme heat. In the last year, Canada especially faced the brunt of very high temperatures, something which was in past, with the temperatures going up in the 40 degrees Celsius. Now, this really affects our electric grid and every single electric company which is producing electricity, because the demand of electricity really changes and all. And that's where not only we have to give very advanced warnings to our citizen that they have to take care, because I read cases like, older couples, they died in their home because of so much heat, because they couldn't take repeated phenomena for a large part of the world. And there, both the medical infrastructure, the ambulance systems, the hospitals, individuals, and the electric infrastructure will have to come in together and sort of, protect and respond very quickly. all the cases, we need very high quality data. Like, for instance, if I knew the internet here in this hotel wouldn't be this nice, I wouldn't have stayed here for like $200 a night. Similarly, if we know that we're going to have a 40 degrees Celsius temperature in advance.
Well, that's definitely the best case study ever, But thank you so much for, really trying hard to answer to our questions, even though, this hotel might have a way better Wi-Fi. We definitely agree on that. But still, I mean, you were mentioning very crucial example out here. And of course, Earth observation and AI is very real indeed. And now let's focus for the next minutes on how we can better institutionalize those two. And maybe first with you, Begum, because I've heard that there is quite an interesting initiative that's been launched, especially in Berlin, the Einstein Center Climate Change and Public Policy of Human Settlements. What the center is actually aiming at, tackling or deep diving into exactly?
Yeah, so that is a quite new center where our vision is to develop Berlin-Brandenburg into a globally leading model region in enacting climate change mitigation and adaptation strategies at the scale of human settlements through research and effective public policy. So it is led at TU Berlin, but there are also other partners such as Potsdam Institute for Climate Impact Research, University of Potsdam, Charité, and Berlin University of Arts. And it has three directions. One is on governance. So there we will investigate which actors, processes, and discourses support rapid decarbonization, and how can effective climate governance be designed at the sub-national level. And the second direction is on pathways, and there we will investigate how policy frameworks, economic innovations, and behavioral interventions create effective mitigation and adaptation pathways. And the third line is on tools, where we will develop novel AI tools to accelerate mitigation and adaptation action that make the best use of big data and AI. So there we will investigate how new technologies and design tools contribute to climate solutions. And at my team, we will take care of development of AI tools for a low carbon urban planning. So we will develop AI-based modeling of building stocks and energy demand. And then these models will aim to help predicting building energy use. So in particular, we will make use of satellite data to predict building heights, edges, and together with the other data sources, we will also work on a prediction of building types, roof materials, and so on. Yeah, that is the main aim. These are the main aims of the center. We are just at the beginning. And we are very excited for that.
And we are too, actually, and I could actually literally see Emmanuel on my side here, like trying to understand better how maybe you guys can mix and match your solutions out there, because we're talking about building and heat, and now you're talking about the height of the building. So, of course, every type of data can be mixed and matched for a better foster solution out there. Thank you so much for that. Pierre-Philippe, let me get back to you on the new feature that ESA is now experimenting. I'm not going to try to pronounce the exact name of the initiative out there because I just can't. I have to admit this. But what you're experimenting in terms of feature is definitely designed to filter data directly on the satellites. Can you please dive into it?
Yes, thanks, Marjorie. The name is in fact FISAT-1.
Okay, I understand better now.
So in summary, we are really living in a very exciting time because AI is going to space. So we are currently using AI for Earth observation on Earth, but we have demonstrated that it can be deployed on off-the-shelf chip, like the Myriad chip of Intel, on board a CubeSat called FISAT-1. So this means that today you are jumping in terms of computing power with a massive jump because usually computer in space, they were protected for radiation, so we were lagging behind the normal capacity. So now today we can put AI accelerator on the satellite and deploy machine learning. It works. We have shown it for cloud detection and intelligent discarding of images so that we download only the relevant data. But this really opens a new avenue on how to do space mission. Imagine you can upload software on your satellite like you do on a smartphone, and you have different apps. Same sensor, the camera of your iPhone, but you use different bands for different applications. This really opens a world of opportunities. ESA is actively looking at this. There are also new business models coming out of this. We have opened a call on ideas.esa.in where you can submit your idea, and we will do 10 studies about the best ideas. I will post the link on LinkedIn, so reach out. And this means with this technology, we will be open to increase latency of products, so sending the actionable information right to the user in real time, increasing autonomy of satellites, making them work as a swarm and making them more intelligent, having more autonomy for deep space mission going on the moon, Mars, etc. So computer vision of rovers, etc. So you name it. But the main aspect is this agility of the machine learning, which enables you to change the application along the orbit. So we are really entering a new era here, and we need the talents that are listening to us to join us to work on this very exciting topic.
Absolutely. Well, if you do have here in this room or beyond the screen an initiative, a project, or a solution for Pierre-Philippe, you can email him anytime. He'll be definitely happy to read more about your amazing projects out there. And actually, yeah, we were mentioning a lot of different layers of technologies when it comes to the AI we can use on Earth observation. Emmanuel, given the volume of high-resolution images, the multiplication of image types, and of course the complexity of deep learning models in computer vision, what are the technological challenges associated with the development of use cases? And I know you have a lot of use cases on your end.
Yeah, so we have discussed a few of them already. So let me just, I'm going to maybe rephrase some of the things that were said. I would classify them in basically two categories. You have data engineering challenges. So like at Neymar, but everybody has the same kind of problems. For the solar potential energy use case, you can imagine that when we train the algorithms or when we want to scale up to the whole territory, to all the 30 whatever million buildings of France to compute this thing, we have to mobilize a lot of images, 3D images, cadastral information, climate information, and so on. And so the data pipeline is really complex, and it's very important to optimize it, both to have the result pretty quickly, but also to minimize the impact you have using all these machines, which is also very important, especially when we're working on energy transition and climate change. So these are full of technology challenges that are very, very complex and that are very, very important because we're really using big data, massive data, and so this is very complex. Now, the other category, I would say, are data science challenges, so about the algorithms. So from my point of view, there are two pretty big challenges. The first one is the one I was mentioning, is the fact that it becomes more and more important to be able to run some algorithms, deep learning algorithms, machine learning algorithms, that are able to manage heterogeneous data. So not only images, but just crossing them with a lot of like geometrical data, regular structured data, and whatever. And it is very important to have algorithms that are able to have all that as input and process them. And when you look at the literature, there is hardly anything on that subject, hardly anything. There is a lot on the very high-level deep learning algorithms for images, but that's basically just images. The second challenge, I think, is very important. Maybe I'm wrong, but I guess that all of us were mostly, when we're doing deep learning on images, we're mostly using pre-trained neural networks, pre-trained deep learning structure, pre-trained that has been trained on regular images, of images on pictures, photos, and come on, I mean, satellite images have a totally different structures, and they, I mean, to the eye, they all look alike. So it's very different. Okay, it works. I mean, the ResNet, the pre-trained ResNet, and so on, it does work for satellite images. But it is likely that there is a huge gain of performance that can be gained by maybe retraining all that just specifically on the satellite images. Now, this is hard because we have to have a lot of annotated images, and we know we're not going to have enough. So we have to use self-supervised techniques, and then fine-tune them for the different tasks. But I think there is a mutual effort to be done by all the actors about that, and trying to build some new structures and pre-train them using specifically satellite images. I think this is something very, very important.
Definitely a challenge for I was about to say near future. No, the challenge is definitely now if we want to go further in depth into the observation of Earth. Now, back to you, Abhilasha. Of course, you're a strong advocate when it comes to using all this data and AI tools to better fight climate change. But do you think that the initiative we're actually diving into this morning here on this panel should be supported and developed by state? Because I'm hearing a lot of different initiatives, and brilliant by the way of private or public organizations, but isn't it supposed to be again an issue supported by the state itself?
Great question. So one of the things, I recently was talking to somebody who was managing a large philanthropic fund, who was looking and making many grant investments in different projects of the same nature, and a few government officials. And something I noticed, and I've been saying as a founder for past 3 years, 100 platforms. It's no use to anybody. So if you're all doing the same things and you're not collaborating, and we're all reinventing the wheel in different rooms at the same time, we're not going to be able to solve climate change. And that is where collaboration is really, really important. And often collaboration happens when there is ample investment made. Because as a startup, for instance, I need to inform everybody sitting in this room that, hey, I have this platform. So don't make a new platform, just help us. I have an API gateway. So if you need your data set on something, you don't need to do all of that coding by yourself. And if you work with us, we can make this gateway better and faster and more resilient. So this is where investment, lower sort of cost of capital investments is very important. So for a founder, especially, or actually academic, a student, an engineer, anybody who's looking to work into climate action very proactively today, we need to have capital available. I always like to give Amazon's bond offering. Amazon raised capital at a lower cost than many full countries. So we really need to see in our ecosystem, in our capital markets, where the money is going and who has the cheapest cost of capital. And often you would find is that oil and gas and plastics have a cost of capital which is way lower, and transaction times for them is way smaller than for people working in, say, AI or Earth observation or satellites or climate action. And that is where I think state push would be really great. However, one caveat is that state push always often comes with a lot of bureaucracy and sort of inability to innovate and be agile. Founders or entrepreneurs do not work like bureaucrats. So there is a much more of experimental. We're going to try this. We're going to see if it happens. We might fail. We might succeed. That kind of a mindset that founders operate with, send me a 100-page project proposal. And I think in this time, in 2021, we all need to really be able to collaborate very fast technically. Being on this panel actually and listening to other panelists, I was like, oh my God, we all need to sit in a room together and we all need to figure out what are each other's strengths, Because at Blue Sky, we have been looking to partner with academics who build really, really good like climate models. But then we have the capacity to do better design, better platforms, like better like coding. So it would be really nice to do what we call separation of concerns in coding, that each party does best thing what they can do. And a lot of this can be enabled and speeded up by the governments.
So if we do hear you loud and clear, actually, so what you're definitely saying here is that multidisciplinary collaboration is crucial when it comes to better fostering these type of solutions, and of course, to the benefit of the population who actually need and depend. I mean, their life literally depends on the solution we're going to be able to develop through AI-powered tools. And in the meantime, yep, states can definitely help, but if they can get, you know, more startup mindset out there and just, you know, not get more into the same old ways of bureaucratic assignments, and just let the entire spirit of agility being spread out there. Did I wrap it up correctly?
Definitely.
Thank you so much. And now, ladies and gentlemen, it's your time to rise and shine. If you do have a question, just raise your hand and a mic will be definitely brought to you. If you have a question there behind your screen, just pass it on the streaming and chat module, and I'll be happy to be your spokesperson on stage. Sir, the mic is yours.
Yeah, good morning. Congratulations on all this great work. Question to the entire panel, not only to Emmanuel, but to Pierre-Philippe as well. On transfers of technology. The GPA has a mandate to advance international cooperation, number one. Number two, we know that these value chains are neither mature, and that a lot can be done to try and advance things in a new way to share better these emerging technologies with the Global South, for example. And Emmanuel mentioned the example of building new, like digital infrastructure, data infrastructure dedicated to some applications, which would need the support of state and other actors. So challenging a bit what Pierre-Philippe was saying in terms of for transfers of technology, you bring the problem owners, the solution owners together in a shaker and you shake it up, it will happen. I partly disagree with that. It will not happen as naturally as that. From your perspective, Pierre-Philippe, from your perspective, Emmanuel, what are the particular areas where we potentially leapfrog from a logic of transfers of technology to a logic of digital and AI commons goods, where we put together for the planet, for the people, some infrastructure that more people can have access to without having to jump through the hoops of transfers of technology. It's not possible at all places. We need to respect and honor private investment, industrial property and intellectual property, but what are these areas where we can leapfrog from transfer of technology, which is tedious, to digital and AI common goods? Any ideas and pathways there?
Very interesting question. Who wants to address it first? Maybe Emmanuel here with me on stage, and then Pierre-Philippe.
So I'm sorry, because the sound is not that good when you're speaking, so I'm not so sure exactly. I understood the beginning of your comments, but what is the exact question? Can you repeat it again? I'm sorry, because the sound on stage is not that...
Since these value chains are not mature, where do you see opportunities to move from a logic of transfer of technology to a logic of digital common goods?
No, but some of the things are mature in terms of, like, when I was talking about the algorithms, I mean, Google, DeepMind, Facebook, and so on, they are all publishing self-supervised learning. This is the state of the art today for images, and we know how to do that. These are huge, infrastructure to run them, but they exist, and it seems to be really good. Now, nobody tries to do that applied on satellite images, for instance, and this is pretty hard. We're trying to do it by ourselves, but we're too small. I mean, we're doing some stuff, but I mean, this is clearly something that has to be done at least a national level, but of course at an international level. But we have everything to start. There is no reason we should not start.
Thank you very much. Pierre-Philippe, maybe you want to address a question too on the question of technology transfer? If we can hear Pierre-Philippe, there we go.
You can?
Yep, we do.
Okay, good. So thank you very much for the question. The logic of common good is in fact a great logic. This is the one we are following up. All the data we create are open source. It's for the world out there. What we are trying to do now is to enhance this data to make it AI ready, to provide the tools, the documentation to the community, so that everybody can develop the application. When I was mentioning the analogy of the shaker, is that you can have the best application in the world, but if the end user is not aware of it, and if it's not coached or helped to have an uptake of this technology at the heart of its practices, it will not happen. So we need, in fact, to nurture also this relationship and to create this data layer and 2 layers of command to have a bigger impact at the global scale.
So let's shake the shaker itself. There you go. We have a second question here, actually, at Institut France.
Thank you very much. My question is about standardization. You pointed out many very interesting use cases using all these satellite images, and in Neymar you mentioned all the data which is geolocalized with various narrowing to be more and more precise. In the different use cases that you've seen, Emmanuel, or the other participants, did you see matters of standardization? Because what I understand is that every part is in a way inventing its own standard, and then we can have many problems of interoperability.
Yeah, this is a major thing. I mean, this is a major thing for satellite images. This is a major thing for health. I can tell you about interoperability in health. This was terrible during the COVID crisis, terrible, because the data are not at all interoperable. So even like at the national, I'm sorry, I'm going to answer with health, but I could transpose it to satellite images. But it's interesting to know that even at the national level, France, when at the beginning, first wave COVID, the different urgency services, they didn't have the test, the COVID test. They coded COVID differently, each their own way. So there was no way to just take all this data, which is, of course, the data from emergency services. It's extremely useful to follow the dynamics of the pandemic, okay? But that was totally impossible because everybody was just doing its own coding. So that's just one example. You had this Lancet scandal where there was this company which claimed that they had gathered data from, I don't know, 60 or 50 countries, and they concluded that hydroxychloroquine was not a good medication for, it was not doing anything for COVID. That was insane. How can somebody gather data from 60 countries and make them interoperable? And at the national level, we cannot do that. It was clear that it was totally wrong. So we have, of course, the exact same problem with satellite images and so on. And yes, of course, this is a major subject, and we have to work all together on that. And just to mention another big subject on health and on satellite images also is the governance of the data. This is a major subject too. On health, basically sharing data, people don't like it. I'm not talking about the citizen. I'm talking about the institution, public institutions, private companies, even sometimes researchers. Even first wave of COVID, they don't want to share because they want to be the first one to publish, and so on and so on. So that's a big problem. It's maybe less crucial for satellite images, but we have the same thing. It's not that easy to have access to a wide set of satellite images, or it can cost enormous amount of money, which are absolutely unreachable at the scale of a small startup like Neymar.
Thank you very much. Who wants to address also on the panel this question of interoperability, which is definitely crucial if we want to go any further and in depth into better AI tools to observe the Earth or Earth? Does anyone want to jump in? Nope. Okay, let's take the next question though. And we have one question over there, and then we'll, go up to the auditorium. First, your question.
Hello, my name is Alan Pike from OECD. So what you said about data sharing, of course, is very, very important. The OECD just recently adopted 2 international legal instruments which are recommendations about sharing data. One is a more general one on enhancing access and sharing of data, and the other one is more precisely on research data from public funding, where the principle should really be that by default the data should be shared, and yes, there are significant barriers to that. As you mentioned, the researchers themselves don't have necessarily the incentive to share the data and so on. So we do have this legal instrument which was signed by 41 countries, and we're looking now to make it toolkit, to make it more practicable, and so on. Now, my question in this regard is, you mentioned some very interesting use cases, but as I see more globally the problem, for instance, with climate change models and predictions, it's also the scarcity and the patchiness of data, and that very, very often you need to do interpolations between different data points which are too far between. And how far are we, from establishing, let's say, a global cloud of data related to climate, where we would have, you have a very granular, for instance, Neymar has a very granular database for France and concerning buildings. But if we enlarge it now, not only to buildings, but to all CO2 emitters, for instance, in the ideal world, you would have a global database where you would have all these CO2 emitters, individual CO2 emitters, and you would be able then to feed it into your climate models, and you would probably get much more reliable models of the climate. So how far are we from establishing this kind of an international cloud, and do you see a role of GPI to play in establishing such a science cloud?
Okay, there are many questions.
Into one question.
Let me try to rewind what you said and start by the beginning. You were talking about precision and interpolation and so on. The thing which is pretty surprising, at least that's my experience from Neymar, which is that we're very little companies to do that. And basically, we're starting from scratch. So the data can be useful even if you are not like in the 98% of accuracy or stuff like that. What you want when you are publishing an academic paper. When we're doing our algorithms, sometimes even 75% of accuracy is largely enough to operate a lot of stuff. So that's the exciting stuff, because there is a huge margin to improve, but even with low accuracy, meaning compared to what we're used when we're doing deep learning and we're publishing papers about deep learning, is enough to do already a lot of stuff. So that's one thing which is very important to say. So we don't need right now, we can do a lot of stuff without a lot of precision. I guess that later we will need that, but we have time. Now yes, you're right, about the fact that for a startup like Neymar to start from France and then trying to do something global, that's a challenge, and that's not easy, because we are relying a lot on open data. We can pay some data, of course, also, but again, as I said, like satellite images at a fine scale, this is out of reach for us, totally out of reach. But then you have also other kind of data, and hopefully there is the open government so that there are a lot of countries that are participating and that are opening more and more data. France is clearly a leader on that, and that's good news, but we have to push that. So role for GPI, yes, of course, there is a big role to play for pushing that, for making more data available, open source data, and trying to do what we've just said before with the question of Nicolas, trying to start this mutualization between different teams, to mutualize all the efforts on different directions, different challenges. This is a major issue, and I think GPI has a pretty big role to play in that.
And if I may, we're definitely back to one of the facts that Abhilasha was stating when she was actually saying that, yep, the major problem for anyone working on this type of data is definitely the fact to not get back from scratch and, you know, like just build on whatever type of research have already been made. And if, you know, at some point some institution or initiative could gather the amount of work already done, maybe you guys could build on way easier on those powerful data sets, so you can create better AI-powered solutions out there. Thank you so much. I think we definitely had like 2 questions here in the auditorium. Oh, first, let's hear from you. Thank you so much.
Yeah, thank you so much for the presentation. It was really interesting. I just have a question about the increasing resolution of remote sensing data. Obviously, we've seen tremendous changes in the resolution becoming even greater than, you know, in the past couple of years. So this is a question for all the panelists. What do you think the privacy implications of increased resolution data are for the individuals and households that are included in this data and may not have any say in consenting to this, and also if these models that might be used in climate modeling are transferred for another use case that may not be as beneficial to society?
And
Thanks.
this is definitely a crucial question again when it comes to privacy. And of course, Begum, Abhilasha, or Pierre-Philippe, if you guys want to address the question, we'll be happy to take your perspective and thoughts. Begum, maybe first.
I believe that development of privacy-aware machine learning models is very timely. It is not only because of the increased resolution of satellite data, but also it is joint use with socio-economical data. So it's a very important and timely topic, and I think as researchers, scientists, we need to invest time and effort to develop robust machine learning models for the privacy concerns. So in this perspective, I think that federated learning approaches can be the right direction. So this is also a kind of answer to previous questions. Nowadays, it is not really necessary to share the data to learn a machine learning model for training. Okay, so it is possible through federated learning approaches that are introduced as a decentralized data analysis approach that enable collaborative training while keeping the data on clients' entities' sites who hold the distributed data sets. And this can be done by just exchanging the model parameters. There is no direct need nowadays to centralize the data, to share the data if it is including privacy concerns, okay? So yes, I believe that in the near future, we will see that the resolution of the satellite data will be much more improved, and this will be much more critical. And we have recently started to work on that direction, but we are considering 2 different applications. One is if the data is combined with socio-economical data, how we should react to this, you know, because maybe there is some data such as household surveys, it can carry personal information, and we would like to design models that will not use that information, that will hide this while extracting Earth observation specific knowledge only.
Thank you so much for this perspective. Abhilasha, I think you wanted to jump in this question too.
I think first part is, the panelists before me answered it absolutely to the T. There are many approaches now which are available for us to evade some serious concerns about it. The other aspect was like, as far as resolution is concerned, for much larger scale applications like emissions monitoring, which I would say does have certain implications around, privacy. We still don't have that high resolutions to be able to kind of bother a lot of individual level data set. And I think a lot of discussion which is happening in terms of the socioeconomic data and the privacy implications of advancing the conversation around that, and the learnings from that spectrum to be adopted in the geospatial or the satellite spectrum, rather than having to, for us to think about this concern at the moment.
Thank you very much. Pierre, Philippe, or Emmanuel, do you want to dive in a few minutes? You already touched on.
Well, no, I would
Leo's
like
data,
maybe
but-
to comment what was just said about federated learning. I think this is a very promising technology. Now we have to be careful. From my point of view, it's still at a state of research, federated learning. It's not totally clear that it's the thing that's going to be the thing in the next few years. Just to give you an element of just some information, I'm leading at the Health Data Hub a consortium, a European consortium that candidates to the pilot of the European Health Data Space. We have a lot of countries in the consortium and so on. The European Commission was very clear about this pilot that we should not try federated learning, because it's going to be really long because you have to secure all the pipelines, to change the APIs of all the infrastructure, existing infrastructure, and so on. I mean, it's not that clear that, for instance, for the European Health Data Space, this is going to be a technology that will be used. Maybe it will. I mean, clearly, and at the Health Data Hub, we are working in that direction where we want to try it. But we have to be careful saying that this is now working and we have to all use that and so on and so on. We have to be a little more careful.
Thank you very much for this precision out there. I've seen a lot of hand raised. First, let me jump into an online question, because the platform is also bubbling with a lot of interrogation for our panelists out there. So you mentioned that the AI used for images are generic, when it would be certainly profitable to have specialized ones on satellite images. But you mentioned also the difficulty of having enough labeled satellite images to train this specific AI. Would there be a solution using current AI to automatically label satellite images and then train a new AI from scratch on these labeled images? I'm pretty sure the question is to you, Emmanuel.
We can imagine several things. I don't know exactly what's going to work. My idea was more to use the state-of-the-art self-supervised learning algorithms. So a combination, of course, of labeled images, but also self-supervised. I mean, self-supervised, at least on regular images today, has proved really very successful. It's really impressive, the results that are that we can get from that. You see the latest papers by, I don't remember if it's Google or DeepMind, but they are doing some really impressive stuff on that. So my belief would try, instead of using the pre-trained ResNet and just fine-tuning them on the satellite images, trying to build from scratch using this self-supervised approach that you would then fine-tune to your use case using the labeled satellite images you will have. But of course, you can also say we should use active learning. There are alternatives, and we should try all of them. You know, there is something that we call data-centric AI today, and I think data is taking more and more importance even in the AI pipeline, and I think we have to be aware of that and trying to push research in that direction.
Thank you very much. Let me take a question second row, and then we'll move 10th row. First you, sir.
Thank you for the floor. We have at the French Home Ministry works on the new space strategy. You know that we have a new approach arriving on this moment in France. One element is the 40-kilo nanosatellites constellations that might arrive in 2 years, 3 years. Some companies exist like Prometheus and other companies, of course. What will be the impact on artificial intelligence of those constellations that might arrive in 2 or 3 years, and especially on the jobs? What kind of new jobs will be created by this link between the new space and, of course, the artificial intelligence sector?
Well, let me address the question to Pierre-Philippe maybe first, and then who wants to jump in will? Pierre-Philippe?
Yes. Good. So I'm afraid I cannot predict the future, but I can look at trends, and what I see is that a bit like we were talking before, it's about hybrid. It's taking the best of both worlds, the more traditional one and the new space. It is clear that the new space companies are moving heavily on AI, both on the planet to do downstream analytics of the data, but also a bit on AI on space and the management of the constellation with AI. So regarding the job, I can just tell you about our own experience. We have a lot of difficulty in attracting AI talent that knows also about the data. So this intersection of domain is still something that is not mainstream curriculum. So I can certainly see a new type of data scientist being good at AI, computing in general, and also having a flavor of the data and the kind of mindset of an entrepreneur to talk to user and get these services used. So I think the job is evolving towards this kind of specific skills, and some of the more traditional, let's say, eye detection, like in the eyes charting jobs, will become more and more automatic. So there will be some shift, I think.
Thank you very much. Who wants to address this question too? No one here on the panel, so let's jump to the 10th row there. And sir, the question is yours.
Hi, woman.
Sorry, I'm so
okay.
sorry, ma'am.
No problem. I don't differentiate much. I have a question. Given that it's the GPACE Summit, I would like to ask all the panelists what they think GPACE could do to address all these important questions people are bringing up. And I mean especially GPACE. So not something that, you know, if you happen to be on a panel at the OECD, you'd ask them to do it. But what is it that's special to GPACE that could be used to address these kinds of problems?
Well, well, well. Who wants to take the question and the answer? Which come with it? Emmanuel, you're not sure about this.
I talked a lot.
There you go. See, oh, okay, there you go. You want to be fair in terms of who speaks now. So Pierre-Philippe, maybe the co-moderator of this session would like to address the question about how GPI can actually help better foster all the matters we've been diving into.
Wow. Thank you very much, Marjorie.
You're very welcome.
Okay, so it's certainly a question that would require further discussion, but it's clear to me that this initiative has a lot of, let's say, power in terms of influencing, and we should use this for the best, for AI for good. In particular, Space, I think, is a newcomer to this conference, or maybe I don't have full awareness, but when I discussed initially my participation, I understood that space was more remote because AI is so agnostic that it can address the whole world. So specifically for our community, I think it's very important to build these global commons we were mentioning before. And because AI is agnostic, we could benefit from technology from the medical world, from the finance world, etc. So there is also an aspect of awareness that you can help us with in terms of exposing people to our data, that they can help the world and work on things that matters. You could really help in resonating this message across the world and across community.
Thank you very much. We do have another question.
I could add one thing.
Emmanuel wants to jump in, and then we'll take the other questions.
I was thinking when I was
speaking.
We can add something about maybe there is a role I think very important to play, which is citizen education. This is, at least for health, this is for me top priority on the list. It's very complex. The subject of data, of AI, very, very complex subjects. It's very hard to understand. Even if you take your mobile phone, it's very hard to understand where is your data. Is it on the cloud? Is it on the phone? What it is used for, and so on. So even when we are expert, it's hard to understand. So for people who are not experts, it's really catastrophic, especially because then it leaves the door open to all the fantasies about what AI can do because people can imagine today that it can do everything sometimes, and we are very far from that, and what it cannot do. Okay, and there are so many fantasies about that. That could be positive fantasies, like yeah, for medical care, AI is going to solve everything, and you know there are some specialists saying right now, I mean, in conferences that people in the audience, some people will live till they are 500 years old or stuff like that. So no, really, I mean, there are some specialists saying that right now about AI. So we have to be very careful. And you have then the dark fantasies about, you know, where is my data and how it's going to be used and it's really bad and so on and so on. It is very important to educate people, not doing oriented education, doing objective education about what it can do, what it cannot do, what are the risks of sharing the data, what are the risks of not sharing the data. There are risks, there are real risks, and then everybody is going to can make a clear decision about, for instance, its own data, which is not at all the case today. I mean, they are deciding, but it's not clear-minded at all. It's like totally blurry. So I think citizen education is a major, major subject, and GPI can do a lot about that.
Yeah, so better bring awareness to whatever AI and data literacy is. And if I may include myself actually in the debate out there, it's also powerful things for us as media to better understand, you know, the end game of what all these debates about AI, regulatory bodies, and trustworthy AI is definitely all about, so that we can also do our job to, you know, not jump into the clickbait, you know, side of the story, but just, you know, give a better understanding of what, I mean, are the powers of AI and its responsibilities at the same time. So, yep, we can definitely dive into this question again. Last question here, and then we'll have to get to a conclusive remarks for this session.
Actually, it's more a comment or maybe a tentative answer to Joanna's question than a question. I'm a co-lead of the Responsible AI for Climate and Environment action that will be presented at 1:30.
Absolutely.
And I mean, this session is about Earth observation. It's about collecting data about Earth, and of course, in the climate change action that we are developing, data plays a central role. And what I would like to say is that GPI, our recommendation to GPI, is to put together mechanisms for data sharing, for interoperability, for building capacity, because it is very scattered. So what GPI can do is join forces together for all these issues that have been explained this morning. So more in an hour.
I cannot agree more.
Yeah, we couldn't dream about a better conclusion, actually, when it comes to your perspective and question sharings. I'll definitely have, okay, let's take this very last question super quick, and then we'll jump to conclusion.
It's going to be very short, promised. I just wanted to thank Emmanuel for talking about citizen education, because it is very important. I don't think we can get very far without educating citizens. And Fondation Abiona, Institut Montaigne, and Open Classrooms have developed an online class without any prerequisites for citizen education. We already have 150,000 people formed in France who completed the course. It's only a 4-hour course. And we just developed the English version of it, and we look forward to people going online and understanding what AI is about and what the risks and opportunities are.
Absolutely, if I may, on a more personal note, I actually tried out this incredible online course, and it's, yeah, you have everything you need to know about AI and how to navigate as a citizen, user, and digital citizen, what AI is all about. Thank you so much for reminding us about this initiative. So, ladies and gents, time to conclude this incredible panel and discussion out there. Pierre-Philippe, do you want to give your first conclusive remark?
Okay, thank you, Marjorie. I think you already summarized the session by saying that there is no planet B. So what we try to do here in Europe, ISA together with other European organizations and an ecosystem of industry and academia, is to build what we call a digital twin Earth, which would bring together the data from space, drones, IoT, open data, in order to get the most comprehensive picture of the planet, and through modeling enables the prediction of the state of the planet. So that you would have a kind of laboratory where you can make experiments, so the digital planet B, so that you understand our impact today and tomorrow. AI will play a key role in there for the different reasons we explained, the data fusions, natural language processing, interfacing with these things like you do with a digital assistant. So there is a lot of opportunities there. This is the main message, to work on this and to work on things that matter. So what we really need is to get these AI talents to have their heads focusing on these kinds of issues and helping the planet A, rather than doing advertising or marketing. So this is really an opportunity for both science, but also to create a new business, new startups, and moving us to the new era.
Thank you very much for those conclusive remarks. Begum, do you want to dive into your conclusion now?
Yes, thank you very much. Two remarks from my side. Yes, we need large-scale data sets, but there are recently available data sets that can be used as the training source. I mentioned about BigEarthNet, but BigEarthNet is not the only one. Very recently, it has been announced that we have now ESA's world cover map. It's at global scale, it's publicly available, and it's a great source for training the machine learning models. And very soon we will hear from Google that there will be dynamic world dataset. I think the second week of December, Google will be announcing it. It will be presented in the ALGO conference. And there are many other benchmark datasets, much smaller scale, but I would suggest you to consider all these datasets instead of computer vision datasets. And a second remark is in Germany, we have AI competence centers. For example, in Berlin, we had Berlin Big Data Center and Berlin Center for Machine Learning. These two competence centers were combined to build a Berlin Institute for Foundations of Learning and Data. There we are educating young talents on AI topics at the intersection of big data management and machine learning. And I think that that will be amazing for Earth observation topics in the near future. I suggest the same strategy is also in France if it's not operational right now.
Absolutely. Thank you so much. Thanks for the invite, though, to brainstorm about this adaptation of this initiative in France. Abhilasha, your conclusive remarks.
I think I will focus mostly on the software part of the thing. So as one of the gentlemen mentioned, we have a lot of satellites going up in 2020, 2023. What we have to focus on building all the downstream stuff. So everything from like cleaning algorithms to any sort of software as a service or data as a service, infrastructure as a service in all of these downstream industries, so that a lot of our satellite data does not just go like, unused, sitting in corners, only to have very high supercomputing power. And if we do want, for instance, Pierre mentioned that a lot of our data sets are open source. And if we do want those open people across the planet in all countries and all continents for different kinds of use cases, especially on climate, and in a speedy manner, because see, you can always do something in a very long amount of time. We need to then build very user-friendly software technologies. How Facebook or Instagram is really easy to use, and how when we log into our bank's online portal, it's not easy to use. So we have to focus on some of those elements of user design, interface design, and like software speed way before we have some of these higher resolution data sets coming, so that as soon as they come in, we are able to incorporate them and inform our decisions to very active and very proactive. Sort of becomes even more, we face more climate events, we are able to respond to them more quickly.
User experience first, of course. Thank you so much. And last but not the least, Emmanuel here with me.
So if I had just one take-home message, I would say, let's do our best to build some common assets, in a mutual effort. So common assets would mean, of course, data sets, of course, data standards for interoperability, metadata standards, algorithms, but also common or kind of compatible governance and clearer governance. So this is very, very important that everybody works together in that direction. Everybody meaning academics world, public institutions, national public institutions, international European institutions, and of course private companies, and not forgetting governments too, that have a big role in that also. And I guess that GPI can help a lot in that.
Of course, GPI can help. We're here for that. Thank you so, so much to the four of you for your incredible perspective. I get there deserves some applause.